was x minus h squared plus y minus k squared equals r squared. Okay, the center is our hk. So my h would be 4. K is -2, so minus negative makes plus 2.
Wait, in our center, one negative.
Oh, I'm looking at the wrong point, aren't I? So x minus 1 squared plus y plus 2 squared equals, we need the radius. So what we know, the center is 1 plus -2. And 4, 2, -2 is a point on this graph. A circle is every point that's the same distance from the center. So how far from the center is this point? 3. So my radius is 3. So 3 squared is 9. Now, I asked you for the general equation. So if you have that handout from yesterday, you can look. It was like the third slide on here. This is center radius. What's the general equation mean? It's all multiplied out and set equal to 0. So if we multiply this, that's like x minus 1 twice. So that would give me x squared minus 2x plus 1. If I have my y plus 2 twice, y squared plus 4y plus 4. And we need it equal to 0, so I'm going to subtract over my 9. Now at this point, I don't really care what order your terms are in. The idea is the general form is multiplied out and equal to 0. So I don't really care if you put the x squared and then the y squared, or if you have your x squared and then your x term. That part doesn't matter. So we have an x squared minus 2x plus the y squared plus 4y. 1 plus 4 plus negative 9. And that would be my general. So that was the only thing we skipped yesterday because we had a short class. Is that okay with everybody? So yesterday I gave you the assignment for those circles. Hopefully you're working on that. Are we close to done? It's due tomorrow. So if you don't have it done and you need help, make sure you're coming to see me or stay after class today so we can get that done. Today we are going to cover the next section, which is functions. And I guess I'm nice 2 days in a row. I did write notes for you once again. Because I had some graphs and I wanted you to have them. Okay, this stuff should be reviewed. So if I have more examples than we need, I might skip some. But if you don't remember something, tell me and I can give you more problems or go over some more. So in the past, probably Algebra 1, Algebra 2, you've talked about the difference between functions and relations. A relation is just any relationship between two sets, any correspondence. Typically, we're looking at sets of ordered pairs. So you have an input, you have an output. If we're talking about equations, we call those x's and y's. So your x is your input, your y is your output. A function is a specific type of relation where each input has exactly one output. Another way to think of it is x never repeats. So if it's a function, your x's don't get repeated. X gives you one answer and it's the same answer every single time. You never plug in the next value and get two different numbers out. Now functions can be represented a lot of different ways. We might see an equation, a graph, but we could just see a table of values, a list of points. a mapping. So I just wanted to look at a few different representations and decide if each of these is a function or not. So would the first one be a function? Yes. What's my domain? Domain is your x values, so that's your input here. Okay. Does it matter if I put those in a different order? No, it's only those 4 numbers. I'm just writing them in a set. They can be in any order. What's the range? If, notice the 3 got repeated, but we don't have to write it multiple times. We just put it once. Is B a function? No, the 3 repeats. We have the same input twice. What is the domain? What is the range? Did we ever even use the -1 though? No, so we don't even really need to list that. The only y values that got used were 1, 7, and negative, or 1, 7, and 4. Okay, you guys take a look at C and D. I gave you sets of ordered pairs. Decide if those are a function. Tell me domain and range. Yes, if we look, all of our x's are different, so it is a function. Domain 1, 2, 3, and 4. What's our range? And D. That one is not because we used the -3 twice. So we can still do domain and range. -3, -2, 0, and 1. Range 9, 4, 0, 1, and 8, but you can put those in order, that's fine. Alright, are we okay if it's listed out like that? A table, mapping, sets of ordered pairs. Let's take a look at an equation. If I said y equals 2x minus 5, would that be a function? So a function means x doesn't get repeated. If I give you an x value, you can plug it in here and you get one answer out. And you get the same answer every time. Okay, so if you give me a number, give me a number. So if I put in a 5, 2 times 5 minus 5, we get 5. Do we get that answer every time? I put in 5. Yes. If I put in 0, I get -5. Do I ever get a second answer? So would this one be a function? Yes. No matter what you plug in for x, you get one answer and you get that answer every time. Okay, what about b? Give me, let's say I put in a number for x, maybe 0. Okay, so I plug in a 0. I get y squared equals 1. So what's y? Plus and minus 1. So if I put in 0, y could be positive 1, or y could be negative 1. Is that a function? No, because I have one x and I got 2 different y's out. All right. I want to talk about domain and range just a little bit. You guys have done this before. Do you remember how to look at graphs and give the domains and ranges? So domain is referring to like your possible x values. On A, I just have 4 points, and I know those graphs are tiny on your handout, so I apologize for that. Your domain, since I only have those 4 points, I only have 4 points in my domain. What are they? Okay, my range. I only have 4 points, so those are the only 4 points in my range. That would be It's the x value of those points. Range is the y value of those points. Now on B, can you tell me every possible x value? No, we can't make a list here. We do an interval instead. Domain is your x's. So if we think going left to right, the first x value we hit would be -1. And do we do a parenthesis or a bracket for our interval notation? Bracket, because it does touch -1. It's equal to. And then if we keep traveling, we're going to hit all the x values until we get to the end, which is at 5. And we do touch that one, so it also gets a bracket. The range is your y, so you have to go small to large. Yes. Yes, this interval notation is saying everything between -1 and 5. So every whole number decimal, everything between them. So your range here, that is your smallest y value. What's the smallest y value we ever hit? -4. It's like starting at the bottom. And then we hit everything until we get to what point? 2. So remember, this is our interval saying everything between -4 and 2. You guys take a second and try C and D. Yeah, you can assume, since it goes off the graph, that it has arrows. So C. Domain, as you go from left to right, it's going forever in the negative direction, it's going forever in the positive direction. What's our domain? Range, bottom to top. It's going down forever and going up forever, so what do we hit? Hit D. Your domain. So this parabola, as it keeps going, it gets wider and wider. So what x's do we hit? Our range, our y's. We're looking going from the bottom up. The lowest point is, and then we hit everything above that, which is, right. So can you give me domain and range from the graph? How do we tell from a graph if it's a function? The x's can't repeat. What did we call that? So if x doesn't repeat, it passes the vertical line test. That means that any vertical line you draw hits your graph in at most one point. So if you can ever draw a vertical line that hits the graph more than once, it is not a function. So take a look at the next slide. It has 4 graphs. Decide if these are functions or not. So what do you think about the first? Yes, no matter where I draw a vertical line, it only hits once. Second one? No. Third one? No, we can draw lots of vertical lines that hit it more than once. This last one, this is showing a graph, it's increasing. It never turns vertical, it's just slowly increasing. So is that one? All right. Are we okay with vertical line test? Let's talk about domain. Domain is asking what your possible x values can be. So if you're looking at a graph, you can just look at it and tell. If I'm looking at an equation, there are really a couple things that we need to worry about. In a fraction, what can't happen? Bottom of the fraction can't be 0. So in any fraction, the denominator can't be 0. And if we have even radicals, so I mean like a square root, fourth root, sixth root, so on. What has to be true if I want a real number? Yeah, if you have a negative under a radical, what do we get? Those imaginary numbers. So if I don't want imaginaries, the radicand thing under the radical has to be greater than or equal to 0. And that's something we will use a lot this year, talking about domains. So this isn't going to be the only time I mention those things. Let's get through just a little bit more, and then I'll probably stop for today and finish this section tomorrow. So I have a whole list of equations. I want to decide if it's a function, give domain and range. There are lots of options for this. What's one way I could decide if these things are functions? What? Okay, so we can plug in points and kind of think through. Will it have more than one answer? That's how we did the last one. We also know something about graphs now. So could we use graphs to check? So we would have to see if it passes the vertical line test, right? Okay, why don't we try that? Since we've already done the first ones by reasoning through, let's double check it. If I wanted to graph it. So if you graph y equals 2x minus 5, what's that look like? Line, y-intercept -5, slope of 2. So is that a function? What's the domain? What's the range? Okay. If I said y equals x squared plus 3, what's that look like? Parabola. It's just been moved up a little bit. Is that a function? Does it pass the vertical line test? Yeah, no matter where you draw your vertical line, it only hits once. Domain. What would that be? The range. If I start at the bottom, what is this lowest y value?
3.
And then it goes up forever, so that would be 3 to infinity. Okay, C. Can you graph this one on your calculator? Nah, the calculator requires you to do y equals, right? Is this written as y equals? No. So there's a couple options. Okay, we solved absolute value equations on our last test, right? So we said that you would make two separate equations, y equals x and y equals negative x. But even if you try doing that on your calculator, it's not going to give you the correct domain, so it's not going to give you the correct graph on it. So in this case, if we can't make it y equals, that should be our first red flag. If it's a function, we should be able to make it y equals. It's not, so this one is possibly a problem. If we think about some points, okay, it'd probably be easier to plug in things for y. What is the absolute value of 0? 0. Okay, if I did the absolute value of 1. Okay, 1. What's the absolute value of negative 1? So 1, negative 1. Okay, do you see a problem here? You put in 2 for your y. You get 2 out. If I put in negative 2, the absolute value of negative 2 is 2. This took my normal absolute value graph and kind of flipped it on its side. Is that a function? No. So the thing that made me pretty uncertain at the beginning is that it wasn't y equals. That was my first red flag. So this one is definitely not. My domain would be what? What's my range? D. Any concerns with looking at this? What's different about that one? The inequality. If you just graph y equals negative x, that's just a line. Slope negative 1, y-intercept is 0. But when you have an inequality, what does that do? It shades. So we're doing these problems to kind of pick out things that make it not a function. You know, when my y was inside the absolute value, if I have an inequality, does this pass the vertical line test? No. If it's an inequality, it's never going to be. What's my domain and range on this, though? Both of these hit everything eventually. That inequalities are not going to give us functions. Alright. Let's do, I guess I only have 2 left. Let's go ahead. Graph this one for me real quick. So this graph turns out a little bit weird, doesn't it? So you kind of have something that looks like this. So is it a function? Yeah. You know, this is getting straighter, but it's never actually vertical. My domain. Where's that breaking point on your graph? Can you tell? It's kind of hard to tell. Look at the equations. What did we say about fractions? The bottom can't be 0. What makes x plus 2 equal 0? Negative 2. So my domain, it's everything but negative 2. So everything smaller than negative 2, everything bigger than negative 2. We'll look at a lot of functions like this later on this semester. My range. Do we hit negative values? Do we hit positives? Do we hit 0? No. So my range is everything but 0. Last one of these. I say the square root of 4x plus 1. So you get what? A little curve, kind of looks like that. Is that a function? Yes. What's my domain? Can you tell? If you can't, we know that in an even radical, the thing under the radical has to be positive. So it had to be greater than or equal to negative 1/4. Does it look like it started at about negative 1/4 on your graph? Should have. Our range, what y's do we hit? The lowest is 0. Alright, a lot of these are functions that we are going to be looking at closer throughout this chapter, but I wanted to go ahead and take the opportunity to kind of discuss some of them, look at things that make it not a function. If you can't solve for y, if it has an inequality, those are big red flags. Last thing, I know I'm teaching for the most of the hour today. Tomorrow will be a very short teaching day, and you're going to have a lot of work time in class tomorrow. So, I just wanted to talk about function notation briefly. Then we'll stop for today and pick up that tomorrow. Function notation, I told you if it's a function, you're going to be able to solve for y. And in that function notation, you replace your y with f of x. When you're reading this, that's your x value. The whole thing, what it's equal to is your y. Okay, so you might see an order pair written in function notation, but just know that the thing you're doing f of, that's your x value, and what it's equal to is your y. So for 2 examples, if I give you these functions, if I ask for f of negative 3, what does that mean? Alright, we go to function f, and I am replacing my x with negative 3. So that means all of my x's become a negative 3. So order of operations, first we do the negative 3 squared, which is negative 3 times negative 3 is positive 9. Then we have another negative in front, so that would be negative 9. Negative 6 times negative 3. We get 13. So when I say g of r plus 2, am I going to get a number answer here? No. It says you are replacing your x with r plus 2. So this time I'm going to function g. So in function g, that x becomes r plus 2. So we get 3r plus 6 plus 1, or 3r plus 7. Any issues with that? So let's find f of negative 1 in each of these instances. So the equation. If we have an equation, that's probably the easiest instance because that's the one you're most used to. It just means you replace your x with a negative 1. squared is 1. 2 minus 9 is negative 7. When I give you ordered pairs, you have to understand what f of negative 1 is asking for. F of negative 1 means find y when your x is negative 1. So if I look at these points, first I have to find the one when x is negative 1. What's our y value? If I give you a mapping, find y when x is negative 1. So what's f of negative 1? If I give you the graph, and I know, I apologize, it's small on your paper. F of negative 1 says find y when x is negative 1. So if I'm looking at my graph, when my x is negative 1, I'm about here. What is that y value? 0.5 or 1. Do we need more examples like this? How much of this stuff do you guys remember? Okay. So here's the game plan. Circles, that section from yesterday is due tomorrow. So if you don't have those done, make sure you get them done. You can check it, ask questions. Then, I believe, did I print the assignment on the back of this? The last slide, does that have your homework? So, this assignment, we are not done with. It will be due on Friday. Now, it's a longer assignment, but you are going to have the majority of class time tomorrow to work. It will I'll probably only teach for about 10 minutes tomorrow. And after that 10 minutes, the rest of the class period is time to work on this. So just know you have that coming. You don't have to go home and spend an hour doing your math homework tonight. But finish the circles if it's not done. And then you can go ahead and start this one. You will have class time tomorrow.